So this is lab 2. Today's lab is about using Excel to perform line fits and other fits to the data. But before we get into that, I want to review some topics from last week's lab and also from class that will be helpful to you as you complete today's lab. Okay, so I want to talk about fitting parameters. I mentioned those briefly for lab 1, but they're going to be more and more important for this lab. Okay, so here are so this is a position versus time graph. So distance, position meters, time in seconds. We have two lines. So what distinguishes one line from another? Well, slope and y-intercept. Okay, so, and again, the slope and the y-intercept, Excel gives you that information. So the slope and the intercept are called fitting parameters. The parameters of the fit, all right? Okay, and again, they have units. They have units. And the units depend on what you're graphing. Okay, so let's look at this line here. So please pause your video and figure out the slope. So figure out the slope of this line and make sure you include the correct units. Okay, let's see if you did it right. So I'm going to, you can pick any 2 points, right? So I'm going to pick this point and this point because they're pretty much on the intersection of the axes. Okay, so the slope is the change in y over the change in x. Some people say it's the rise over the run, whatever you want to call it, right? And so the y-axis is the change in distance. So we have the change in distance over the change in time. Okay, so I'm saying this is the final point and this is the initial point. So the change in distance is minus, okay, so what's the distance here? Minus 15, what's the distance here? Minus 5. So minus 15 minus a minus 5 is minus 15 plus 5, which is minus 10. Meters, right? Meters. So the change in distance is minus 10 meters. And the time, so this is 7 seconds. This is 2 seconds. So 7 seconds minus 2 seconds is 5 seconds. 5 seconds. So that's negative 2 meters per second. All right, so that's the slope, negative 2 meters per second. Okay. And I mean, here's what Excel gives you, right? You tell Excel to give you the equation of the line, and it gives you this. And so, you just look at this and see the slope is minus 2, but remember, it has to have units, minus 2 meters per second. All right, so let's look at, so again, Excel gives you negative 2x minus 1, right? Okay, so that's the equation of the line. So what are the units of the y? Well, look at the graph. Distance, meters. So this is in meters. What are the units of the x? In other words, the time. Seconds. So the x is in seconds. Seconds. So just from this, okay, I'm just repeating myself, right? I'm doing this a different way. Just from looking at this, what has to be the units of the 2 or the negative 2? Well, meters equals meters plus meters, right? And so the 2, it has to be meters per second because this, the 2, is multiplied by the x, which is in seconds. So you have a meter per second multiplied by the second gives you meters. Okay, so the units of negative 2 are meters per second. No kidding. All right, that's the slope. All right, and of course, what are the units of the negative 1? Well, again, meters equals meters plus meters, right? And so the negative 1 has to have units of meters. So if, in other words, on the lab report, this is what you should say. You should say the slope equals minus 2 meters per second. And then the y-intercept equals negative 1 meter. If you do this, you get it wrong, right? Because what does that mean? It doesn't mean anything. You have to have units. Okay, you have to have units. Okay, let's do another example. I'm going over this in gory detail because I've learned over the past few years or many years that people still are having trouble with this by the third lab, so I'm trying to avoid that. I want you to get it, understand it now. Okay, so here's a velocity versus time graph. And so, the fitting parameter is going to have, different units. Okay, so let's do it. All right. So everybody pause your video and figure out the slope, including units, please. All right, let's see if you did it right. So I'm going to choose this point because it's right on the intersection of the axes and this point. And let's do it. So the slope is the delta y over the delta x, or the rise over the run. And here we have minus 40, minus 20, that's minus 60. So minus 60, and what are the units? Oh, you can't see them, sorry. That's velocity, all right? Trust me. There, see right there. Velocity, meters per second. So meters per second, delta x is 8 seconds minus 2 seconds, which is 6 seconds. 6 seconds, so you get minus 10. And what are the units? Meters per second squared. And that should be no surprise, right? Because, that's acceleration, right? Acceleration is a change in velocity over the change in time. And the units are meters per second squared. Okay, so that's one way to do it, just from the graph. Okay, now what you do, what we're going to learn today is we're going to have Excel, figure out the equation of the line. And I realize you can't see that. Oh, that's all right. So Excel says that the equation of the line is y equals minus 10x plus 40, right? Yeah, plus 40. Okay, so what are the units of the y? Well, that's velocity, meters per second. So meters per second. So what does that mean? That has to be meters per second. That has to be meters per second. That has to be meters per second. All right. What are the units of x? Time. So it's seconds. Seconds. Okay. So therefore, what has to be the units of the 10 or the negative 10, however you want to look at it? What has to be the units of the 10? Well, we want to get a meter per second, but we have a second. So we got to get a meter. And then what? We want to get meters per second. We have a second, so it has to be meters per second squared, right? Because a meter per second squared multiplied by a second is a meter per second. Okay. So there you go. Are you surprised? Better not be, right? Okay. What has to be the units of the 40? The y-intercept. Well, it's the remember, meter per second equals meter per second plus meter per second. So it has to be meters per second. So again, if this was your lab report, you'd say the slope is minus 10 meters per second squared, and the y-intercept is equal to 40 meters per second. Okay. All right, one more example. So this is called a trajectory. We'll talk about that in class if we haven't already. So this is y versus x, right? There's no time, it's just y versus x, all right? So that's what you see, y versus x. Okay, and so, we're going to learn how to do this in a couple of minutes. So you plot the points, and then you tell Excel, Excel, give me the equation of this curve. And Excel gives you the best fit the best equation. So it's y equals x squared minus 6x plus 9. So it's a parabola. Okay. Okay, good old parabola. All right, so what are the units of the y? Well, meters, right? You know, the y-axis is the distance in meters. So this has to be meters. All right, so therefore it has to be the units of x squared, meters. 6x, meters. 9, meters. Everything's meters. Because you have to have meters equals meters plus, you know, okay. All right. All right, now it's your turn. Oh my gosh. Okay, this is bad. Help! Any brilliant ideas how to fix this? Yeah, I don't know how to do that. Oh. Yeah, hold on. Can you pause?